Is it the little Titan, the legendary Titan, the lightweight Titan? Who knows, but it's right here and it's a beast. Thanks for joining me. I'm Zach from MotoCrane, and today's video is all about all things technical with Titan LT. We'll be going from flight cases all the way to operation with all the nitty-gritty details in between for configuration, payload building, balancing, wheels, controller, and everything in between. We'll also be highlighting some of the important features we've added and updates we've made in the new 1.1 firmware update, which is of course shipping with LT and will be available for big Titan users as well. So let's get into it. Let's start by unboxing a Titan wheels kit, and in this case we have the triple wheels kit upgraded with both brass and aluminum. Inside each of these cavities we have a Titan wheels module with of course one of the wheels already installed, and then the upgraded set here as well, brass and aluminum. We have two sets of short and also long wheels cables for connecting these to the Titan controller. And then we also have hardware here for assembling all three wheels onto the battle station and terminating that with a Mitchell base for building a nice operator station on a set of sticks. For LT, we've split the flight case set into two different cases. The controller case that you see here, and then also the gimbal case that's sitting underneath it. Of course, you have the Titan controller here that comes standard with the 2-axis joystick, as well as the focus knob. And then above it, we have the 3 lens control motors, we have a camera dovetail, the camera top rail, some long and short antenna options for both the controller and the gimbal, bridge plate and 15mm rods, cables for both power and control, as well as hardware and tools in this cavity, 3 different joystick options, and then also the 50mm tilt cage extensions that can be installed for taller camera packages. And the second piece in the LT flight case set is of course the gimbal case, which has the LT gimbal, room for longer comm and power cables, TB50 battery sleds. We have our male Mitchell mount here, as well as a spacer for when you're using both the male Mitchell and the TB50 battery sleds together. We got the quick disconnect set, and then a cavity here for smaller miscellaneous cables. So for today's demo, we're going to be using the quick disconnect. I'm going to align the MotoCrane logo here with the front of the LT pan housing, and then fasten it with the included M5 fasteners. And of course, if you don't want to be using the quick disconnect, you can also be using our LT male Mitchell mount, which also has a spacer that you can use for adding on top for compatibility with the TB50 battery sleds. The LT male Mitchell has the Mitchell key installed at the 0 degrees position, but you could also move this to any of the other threaded portions around the male Mitchell in the event that you needed to clock this differently for your specific camera support. So for the demo, we're going to be using the LT quick disconnect, but in order to get this mounted onto a Mitchell base, we're going to use our male Mitchell, and instead of mounting it directly onto the LT pan housing, we're going to mount it to the quick disconnect. Now on the LT male Mitchell, there is a key that comes pre-installed. I'm going to place that away from me just so I know how I'm orienting this and I'm aware of how that key is going to affect my alignment of the pan housing. I'm going to use the hardware from the quick disconnect hardware bag. These are going to be the 4 M6s, or the slightly larger. And now I'll install those fasteners. So there you have it. You got a male Mitchell on top of the LT quick disconnect. Obviously this makes it easy to have many of these configurations or combos amongst all the camera supports that you'd be using for LT, and you can pop your LT between all of those platforms. So I've got 2 Mitchell-based tripods, one for LT and one for my operator station. I'm gonna take my quick disconnect and mount it to my set of sticks here for LT. Now I've got my quick disconnect here mounted already on LT, and I'm gonna do this so that we can see the pan housing on this side. The quick disconnect has 2 sprung latches so that when you are fully installed, you'll hear a click and it can't come back out. And then we'll move our locking lever to the locked position to make sure there's no play in that dovetail. When using the LT quick disconnect, you can install LT from either side. Just note, of course, that that's going to change the orientation of where your connectors are coming. I have it installed this way so that we can see and install the connectors from this side. We're going to get LT from its packed position into more of a neutral position for mounting our payload. Now the tilt cage has been adjusted upwards for that packed position in the flight case, but I'm going to loosen up my tilt adjust knobs and drop the cage down so that we're in more of a neutral position. I want to make sure that my elevation marks, or for my tilt vertical balance, are the same from side to side. So before we get into mounting of our payload, let's take a quick walkthrough of LT and point out some notable features. Closest to me here on the front is our pan housing connectors. We have a COM connector, power input, SDI video feed, power on-off button. We also have plates on both sides of the pan housing for mounting accessories. These get removed to install the TB50 battery plates. Have our pan axis lock that you saw there, and then also for pan lock knobs for when we're adjusting our pan balance via this balance knob on the front. Coming around the back side here, we have our spine screen, which is a 3.5-inch touchscreen full color display. So we're making configuration and tuning changes up on the gimbal itself when it's easier to actually see what's going on. Again, this is a touchscreen. You also have some physical buttons here as well. And underneath the spine screen here in this overslung configuration is the wireless radio module. This is user interchangeable. The standard radio that's included with LT is 2.4 gigahertz, but users can opt for the upcoming 900 megahertz or sub-gigahertz radio modules that we have, and those will be plug and play right in that location. So really nice there. Now moving our way up here, we have our roll motor housing, roll motor cover, and this roll axis lock that can be locked in 4 different positions. Working our way around here, we have, of course, our active or larger roll arm. We have a smaller, we call the passive roll arm on the other side. Tilt motor housing, tilt motor cover. Getting into the camera cage here, and on the other side, just a quick mention, this is the GPS antenna. So this is used by the GPS assist function for Titan and LT, basically to measure lateral velocity for horizon holding during dynamic applications. And then onto our camera cage right here, we have our tilt vertical balance locks. Of course, we have tilt axis locks here for locking in different positions. We have a base bar slider here where the payload gets mounted, and we slide this back and forth for fitment and also for roll balance. And then the crossbar here has a similar slider for accounting for that roll balance. And then the crossbar is also totally removable. I'll move the tilt axis so we can get a better look at the camera connections that are available. Starting on this side, we have connections for our 3 lens control motors, also a spot for our camera integrations. 3 different ports here for our 12 volt accessories, and then 1 for our 24 volts. And then of course our SDI connection there as well. And on the bottom, you have a good view at these little protective feet that we've added to the LT production units. In the event you want to set it down in an underslung position, this is a nice contact point where you can set it down and you can work on it on a table or something, and your connections and all your cables would be protected. All right, in this section, we're gonna be building out our payload for LT, which is really similar to the Ronin 2 if you've ever built out a camera package for that gimbal. In fact, LT uses the same lower dovetail, so if you do have a camera package and even some mounting hardware that fits with the Ronin 2 that you like, you can even use that for this section. But I have a Red Ranger here, which is the larger DSMC2 body from Red. I have a Zeiss LWZ, which is a nice small to medium size zoom, matte box, Teradek. We'll get all this put together. Then of course, some lens control motors from MotoCrane as well, so we have a fully featured payload. Of course, you could add things like a cine tape or other accessories as you see fit, an MDR, but this is where we want to get all that stuff put together before we get it into LT. So I'm going to start by attaching my lens to the camera body, and then after we're done with this step, we're going to attach our LT bridge plate. Now, I like to work on payloads with them in a vertical orientation. It gives me access to all of the threaded features around the body, as well as easy access for adding my lens support and my lens control accessories too. So obviously, take caution when your payload is in this orientation that it doesn't tip over. But we're gonna start by adding the LT bridge plate and our rods to the bottom of the Ranger here. And you'll find the camera screws in the hardware bag, as well as the necessary tools for using those in the LT tool set from the LT gimbal case. Now again, if you're coming from the Ronin 2, the bridge plate is gonna be a very familiar design. You basically have articulating 3/8 mounts on the bottom so that you can position these however you want, kind of sliding the dovetail that gets mounted here fore or aft. And they also get out of the way for accessing the camera screws when we mount this to the bottom of our camera body. So move these out of the way first. We'll drop in our 1/4 or 3/8 screws. In this case here, I got 2 3/8 threads that I'm gonna use. So I'm gonna thread these 3/8 camera screws right into the bottom. I have these 2 3/8 fasteners that are captive now in my bridge plate, and I can get those mounted to the bottom of the Ranger. So you can see I got my camera screws mounted and my bridge plate is attached to the bottom of the Red Ranger here. I can now slide these to wherever I want them to be for the dovetail that I'm using. So obviously this we can accommodate the included LT dovetail. Also, if you're using something like a third-party Cinemill dovetail, you should be able to mount this up kind of whatever bolt spacing that you need. So we've got our LT dovetail here that's included. There is a laser etch on this, or an arrow that's pointed to the back of the camera package, which basically indicates the way that it slides into LT. This is the same as what it would be on the Ronin 2. So making sure this is pointed to the back or to the direction that it slides in. So I'm going to take these included 3/8 16 fasteners, make them captive in my dovetail, and I can get those added to those two threaded spots right on the bottom of my bridge plate. As we're making some decisions about where this dovetail is being positioned, we want to try to get it right into the middle of the camera package, because that's probably where our tilt depth balance point is going to be. If we sit it too far back or too far forward, we might not have the adjustment that we need on that dovetail when we get to balancing later. Now we're going to add our 15mm carbon fiber rods, slide those in from either side. So we got bottom of the support on the Payload pretty well sorted. We're going to get our lens control motors added and then move on to lens support. Now, one of the unique things about the Titan ecosystem that I'm really proud of is the fact that we've developed our own lens control motor here at MotoCrane. And with the latest firmware, I'm really proud of how these lens control motors perform. The motors that we're using in here are more powerful than a Preston DM2 or a Hedon M26 or even the Aries CLM4. It's a really, really great motor, and we're offering them at a really, really competitive cost. So for those that are looking for a full gimbal ecosystem, inclusive of something like lens control, this is a really great option. So we're going to be using those here today. Of course, LT and Big Titan are compatible with that Preston DM2 motor, as well as the Hedon M26 and some others. Now, before I get my last lens control motor on, I'm going to get my lens support in place. Oftentimes, when you're using a zoom, your lens support is going to be mounted in between your zoom and your focus motor. Just a note to make sure you get lens support in before you get your motor all mounted up. So with lens support installed, I can add my third motor. So here we got kind of the meat of our camera package here. We got our camera body, we got our zoom lens, and then of course we have our 3 channels of lens control motors that are mounted up. Just to add a little bit more heft to this camera package, I'm going to add a Teradek transmitter as well. Remove our lens cap here and get a matte box installed. For gimbal applications, I always prefer a matte box that mounts directly to the housing of the lens. There are, of course, swing-away style matte boxes as well, or other kind of clip-on. The more secure that you can make this matte box, the easier time you're gonna have, especially during tilt tuning. Loose matte boxes sometimes accumulate vibration and can often resonate and oscillate and cause problems for tilt tuning. So the stiffer, the more robust of a matte box that you can throw on for a gimbal application, it's gonna only do you favors later on in tuning. The last thing that I'm going to add to my LT payload is going to be the camera top rail. This Ranger body here that I'm using gives me a really easy time because it has tons of 1/4-20 mounting points on top. For the camera top rail, it's best if you can grab 2 points on the payload for mounting. That will prevent this from rotating or becoming loose over time as it gets rotated. In the same vein as the dovetail that we mounted earlier, we also want to make sure that the camera top rail is about in the middle, or at least the slider portion here can get adjusted to the middle. Again, that's going to make sure that we have enough room to slide the payload back and forth during tilt depth balancing. So now we're ready to mount this payload into LT. Now with the crossbar removed, I'm going to get into mounting the payload. Push until I hear a click. The click tells me that the dovetail is captured and it's in a safe position where it can't fall out. And then I'm going to position the payload roughly balanced forward to back. And then I'm going to use my locking lever here to make sure that the dovetail is locked in place. Now I can take my crossbar here, slide it over the top of the uprights, and connect it to the camera top rail. Now for this particular payload, we had enough vertical height within the camera cage to accommodate this payload. But if you're using something that has maybe a short top handle or a taller bridge plate with rods, you might need to mount the 50mm cage extensions to accommodate that taller payload. The cage extensions are really easy to install. Take the supplied hardware, drop them down through the mounting holes, and then position them over the top so they match the profile of the cage uprights, and then repeat that on the other side. Now, before we get into balancing this payload, we want to make sure that everything is mounted to it. And what I don't have yet are cables for my lens control motors, SDI, or camera power. So I'm going to get those added, and then we'll get into payload balancing. The first axis that we're going to balance is going to be our tilt depth. So this is moving the payload in and out to make sure that it's not front heavy or back heavy. Making sure that I have the tilt of the camera cage supported, I'm going to unlock the tilt axis and feel if it's notably front or back heavy. So right now it's back heavy. I have my tilt axis locked. I'm going to loosen up my camera top rail as well as my dovetail in the bottom, and then make a small adjustment pushing the camera back. So the tilt depth is pretty close. I'm gonna move on to my tilt vertical balance and then come back to the depth to make sure that it is still correct. So you can see here that this payload is very top heavy right now. It means I need to slide it downward. So with the tilt axis locked again, I'm just going to loosen up my vertical adjustment and I'm gonna let it drop down, making sure that my vertical cage marks are aligned on both sides. Still quite a bit top heavy, so I'm gonna come down even more. So you can see I've got it balanced just to the point where I've gone just a little bit too far, where now it's starting to drop a little bit more forward. So I'm gonna push it back just a little bit. Otherwise, we're very, very close. That looks great. I'm gonna lock that down and then, as I said, come back to my tilt depth to see if that is still good. And this looks to be pretty great. I can lock my tilt axis and move on to my roll axis balance. So I'm with my tilt cage and my camera cage supported. I'm going to undo the roll axis lock and see how far off it is in what direction. So you can see that it is falling to camera left or to my right hand side here. I'm gonna loosen up the crossbar slider here on top and also the base bar slider down here underneath. And this is gonna allow the payload to slide back and forth on the roll axis. I'm gonna unlock the roll axis. And it looks pretty good. I think I went a little bit too far. I'm gonna push it back just a hair. And that looks pretty great. Tightening down both my crossbar slider and my base bar slider. Now, to make sure that I haven't messed up my tilt balance, I like to do a check of both axes at once and make sure that we can hang in a 45-degree deflected position for both axes, for both roll and tilt. This proves to me that I have a good balance or an excellent balance on both the tilt as well as roll axes. So now I'm gonna get this back into a normal position and we'll finish up balance with our pan balance. Now, we talked about before these being our 4 pan balance lock knobs. I just have to loosen those up and make sure that my pan axis is unlocked. And I'm just gonna carefully tip the tripod back so that I'm inducing or deflecting the pan axis a little bit, which should reveal some kind of imbalance. And we can see it's a little bit front heavy. I'll do that again so you can see. If I put it perpendicular to me, bring it like this, and you can see how it falls to the front. So it's an easy trick for doing this in the event that you don't have a dampened U-joint or something. This is an important part of pan axis performance, is making sure that the axis is balanced. So if you do have a set of sticks, you can use this method, or if you're using like an underslung mount, you could use like a dampened U-joint or something like that to deflect the pan axis away for assessing the balance. And this balance looks excellent. I'm not able to get it to move when I deflect it back. So we've got our payload installed, all of our cable connections are accounted for, we are balanced on all 3 axes. We're ready to move on now to building the rest of the system and getting everything connected. So using the components supplied in the Titan Wheels kit, we're gonna assemble our battle station, starting by mounting our 4 M6 standoffs to the bottom of the battle station, which gives us a nice base for adding our male Mitchell for attaching this to a Mitchell base. Now, I'll give you a pro tip here for assembling your battle station. Oftentimes, you're gonna be putting one of your wheels in the middle position, and how this bolt pattern is oriented for the male Mitchell, oftentimes this standoff right here gets in the way of cable routing. So I tend to not add this 4th standoff to give me more room for cable routing. I'm gonna remove the nut from my male Mitchell and then position this male Mitchell over those standoffs and mount it with the supplied hardware. Now we got our battle station built, and this will serve as a nice sturdy base for mounting our Titan wheels as well as our controller in one operating station. We've got our battle station built here, so we're gonna remove our Mitchell nut and get it added to this Mitchell base. And again, this is gonna serve as a platform or foundation for building out an operator station. I'm gonna remove the active and passive brackets from the battle station so I can mount those to my controller. The active bracket is the one that has the fastener in it, and the passive bracket is the one that does not. and these two get mounted in a specific orientation on the controller to work with the standard configuration of the battle station. And then we're gonna take those battle station brackets that we just removed and install them onto the Titan controller. Voila. Now we can add the controller to the battle station. The easiest way to mount the controller to the battle station here is to hold it out in front of you with one hand, and then use your right hand to install the brackets. So I'm just threading this into the rosette that's already installed on the battle station. Before it gets too threaded, I'm gonna switch hands and then thread this one in over on this side. And then it gives me that good rosette clicking, so I can put it in whatever position that I want, and we'll lock that down right here. So now we're gonna get our 3 wheels mounted up to the battle station and get them connected to the controller. We're gonna use one of our auxiliary comm cables out of this port here, down to one of the Titan wheels, and then just daisy chain the rest. All of the Titan wheels assignment is done in the controller, so you can connect them in any order, just as long as they're all connected on the daisy chain. So I'm gonna use one of my longer Titan wheels cables to go from the controller here down to my first wheel in the chain. And then I'll go ahead and use 2 of the shorter wheels cables and connect the next 2 in the series. With my Titan wheels modules connected to the Titan controller, I can now decide how I'm going to power up my Titan controller and also how I'm going to be communicating with the gimbal. Of course, the options are wireless or hardwired. In the event that I'm going to be using a wireless connection, I need to populate the V-mount battery sled back here with a power source. Included with your LT are 2 different size antenna. The larger of the antenna is preferred to go onto the controller. And then of course the smaller, what we call stubby antenna, are preferred to go onto LT, onto its wireless radio module. So we're all set up for wireless operation, and if we wanted to go hardwired, we simply need to add a COM cable from the COM port on the controller to the COM port on the gimbal. So the last step before getting everything powered on is connecting a 48-volt power source. We're going to be using the MotoCrane Titan battery, which is of course our tested 48-volt power source for Titan and LT. Start by connecting the twist lock side of the cable to LT. And then last, we're gonna use the QS8 connector, which is an anti-spark connector for connecting to the battery. When connecting the QS8 battery connector, it's important to make sure that it's fully seated. This makes sure that the anti-spark circuit is fully engaged. Sometimes if you have it partially connected, it can actually get hot. And this makes sure that it's a safe start connection when you're applying 48 volts power to the rest of the system. So we got the Titan battery connected. Of course, if you're using the TB50 battery sleds, that also is a totally suitable method for powering LT. But now we're ready to power on the system and get into configuration and operation. So we've got our payload built, mounted and balanced in LT. We've got our operator station built how we want. We're ready to power up, configure, and get into operating LT. To turn on LT, we just press and hold the on-off button, and we'll get a green boot light there on the power LED. And then after a couple of seconds, after the logic boots up, you'll get a blue LED for comm. It means you have successful communication. At the same time, we can turn the Titan controller on. You can have that on already when you're booting up LT. That's not a sensitive order at all. And with the Titan controller, we'll get into kind of an overview of this layout of the user interface. Now, if you're a Titan user, not an LT, but a Titan user, you can also use this section of the video for understanding the new 1.1 firmware that is coming for Big Titan as well. We've made a lot of really exciting improvements and changes to the system, added some new features based on feedback from customers, and of course that firmware is launching with LT, and we are currently porting that over for Titan users as well. So let's start with a quick overview of the Titan controller. Of course, in the middle here we have a 7-inch full-color touchscreen display. We have 2 user interchangeable input modules on the left and the right-hand side. We have some rocker joysticks on the sides of the controller here as well. Of course, on the top you already saw the connector ports. We have a COM port for hardwired communication with LT. We also have an aux-com port that we're using, which basically extends the CAN bus communication to other devices. In this case, we're using it for Titan wheels. We have a USB for doing firmware updates, and then here is our pocket for our wireless radio module, and this is interchangeable as well. Up on the front here, on the top, we have speed pots for pan, tilt, roll, and zoom. So this is to change your operating speed for any of those axes when you're using joystick. There's different speed pots for when we're using the wheels. And then motor on off, tilt direction inversion, and then some user assignable buttons that we'll get into later. But the Titan controller is really a standout part of the Titan ecosystem, a very, very user configurable and intuitive control surface that, again, I think really stands above any other control surface that I've ever used or been exposed to. It's really one of my favorite parts of the whole Titan ecosystem. So looking at the Titan controller here, setup is basically choosing a tuning preset first, and then getting into the rest of the other configurations that are more user or application specific. So to start, we're gonna go to our tuning menu, and we're gonna go to presets, and then choose between the small, medium, and large preset to start. Now, our small preset is built around camera packages around 9 to 10 pounds in size. Our medium preset is actually built around this camera package here, which is about 19 to 20 pounds. And then our large preset is built around camera packages that are about 30 pounds in size. So much, much larger, really hefty camera packages. We also have a handy chart in the operation manual to help you figure out, based on your body and your lens that you're using, where that would fall within the presets. So I'm gonna choose this medium preset here. It's gonna give me the prompt to just remind me that I'm gonna erase the current values that I have in the tuning and write the medium preset here. So I'm gonna confirm that. And now we're all set with our medium preset. The 1.1 firmware that LT ships with has our latest Gen 3 sensor fusion, which of course has been optimized for even more precise gyro stabilization. And as a part of that, we've also updated the Titan controller interface with a new tuning layout, which has been optimized to make it more intuitive and easier for users to get excellent stabilization results. If you're coming from FreeFly or DJI ecosystems, these tuning parameters are gonna be familiar to you, and they function pretty much the same way. Stiffness on the left here is how precise or how stiff the gyro stabilization loop is operating at. And this is gonna be the primary lever that you pull when you're doing tuning changes. Now, one of my favorite additions to this new tuning interface is the gyro meter that we've added for all 3 axes, which lets you monitor exactly what the gyro is seeing, which is basically measuring the stabilization and measuring the stability for each of the 3 axes. So for us, sometimes it's hard in a tracking vehicle to really see if the image is looking good or the monitor's just shaking. The gyro meter is a great tool to use in real time to make sure that you're getting great stabilization results. Now, moving to the right here, the next value is control, and this is essentially a damping value that helps the axis stop at the target and not overshoot. Typically, this value is great to stay at the preset and doesn't need a lot of messing with. And on the far right here, we have strength, which is basically a baseline offset to the motor strength that is applied during gyro stabilization. And having a little bit of strength applied can really help in dynamic stabilization environments. So with our preset selected, we're ready to get into operation. There are a few other configurations that you can make in the tuning screen before we get into operation. You can choose between our acoustics optimized or our near silent operating mode, which is our studio mode. Or if you're in a tracking vehicle and you don't really care about a little bit of acoustic noise being made by the gimbal, you can go into dynamic mode and get a little bit more peak stabilization performance. We typically recommend operating in studio mode. Another great feature of Titan and LT is our GPS assist, and that uses our GPS antenna here and satellite latching. And this is important for tracking vehicles where you are under sustained lateral acceleration, or again, you're gonna be going down the freeway. This helps the gimbal to know where it is in space and know what direction it's pointed, and it keeps horizon rock solid level. So in this environment here, we're not going anywhere, I can keep GPS assist off. Another really exciting feature here that's shared between Titan and LT is the ability to turn gyro stabilization on and off. So of course, when it's on, it's acting as a gyro stabilized head, but there are environments where, say this, the system is locked off and you're just doing a locked off shot and you want to just turn gyro stabilization off altogether, you can do that with the push of a button here. And this is really important. This is typically only reserved for heads like the Libra, Matrix head, but this is really nice when you're in an environment where you kind of want to lock the head off. You don't want to have to deal with anything gyro related. Basically allows you to operate the system as a non-stabilized system, and you don't have to change anything else about how you operate. So you can just toggle gyro stabilization on or off, and that is for all 3 axes at once. Now, LT, like its big brother, is a safe start system, meaning that when you turn the system on and turn the controller on, the motors do not start stabilizing automatically. You must first arm them. And to arm, you have 2 different options. The first is by pressing the arm button here on the back of the spine, and now your motors are armed, and they could be turned on at the controller. Let's say that you have first AC that comes up and they need to do a card change or something. They just can press any button on the back here. It'll disable the motors. They can do their card change. Then you just ask that they arm as they're walking away. But let's say that they forgot to do that, and now LT is inaccessible and they forgot to push that button back here. So I'll say the motors are disarmed and LT has gone away. We have a really, really great override feature built in to the Titan controller so that you can actually do that remotely. We're gonna go to our system page and then to overrides. And now we actually have 2 remote or digital buttons that we can push that will arm the motors remotely. In this case, we're going to press motor arm. It's gonna give us the same prompt here. It reminds us that Titan will rotate and be able to be moved. And now motors are armed. And you can see when I do that same process here, it will actually update the screen on the spine as well. So if I disarm them, it changes the screen there. And again, I can arm them again, digitally pushing that arm button, and now we're armed. In the same way, we also have a remote power on off button. So in that same application where say your LT is up on the end of a techno and you need to do a power cycle, you're gonna break for lunch and you turn everything off, or you want to turn everything off without having to bring it in and access it, you can do that right here from the Titan controller. And I can just press power on off, power off Titan, and you can see it has now turned off. This will turn off your accessory power, so if you're powering a camera or other accessories via LT, just note that it will turn off those accessory outputs as well. And then to remotely turn the system back on, it's the exact same process. I just press the power on off button here. Up in the header, it's telling me that it's currently in a boot state. It's turning on, power is now on, and we're ready to go. And I can proceed with arming the motors in that same way. Motors are now armed, and I can turn them on or off. So really handy feature, again, especially as a remote head that can be in remote places, you still maintain access to these critical buttons on the back here. So with motors armed, I'm ready to turn them on, and I can use my motors switch here on the Titan controller, and now I'm actively stabilizing. And as I'm moving around, you can see the gyro meters are lighting up, and that's showing me the rotation on each axis. And that's gonna come in handy for isolating stabilization issues and which axis it's coming from. Now let's get into configuring the rest of the system. Going back to the home screen here, I'm gonna first jump into my control menu. And control is specific to the controls that are up on the controller. It does not affect what is happening down on the wheels. We have a separate page for the wheels that we'll look at after this. So we have, of course, our 3 axes here, pan, tilt, and roll, and then a few familiar settings like smoothing, deadband, and expo. And again, this is specific to when they're being controlled by the Titan controller. I can bring smoothing up a lot and get a much smoother start and stop. So if we watch the pan axis here, when I let off the joystick, we're gonna have much smoother action on starting and stopping. Of course, the compromise there is the precision that you have for tracking, but this is a total operator preference thing. I tend to operate around 80 to 90 in my smoothing. So I like this. This still feels precise, but I do have a nice tail on that move where it does land in a nice smooth way. And I can adjust each of the 3 axes to be how I want them. The next value here is deadband, which is basically how much wiggle room the joystick will have before it starts commanding the motor. With deadband too high, you might have a little feeling of latency, like you have to move it too much to get it to start moving. But if it's too low, even when your hand is not on the joystick, it might actually be sending a command that might be like 1 or 2. So sometimes people will put their deadband down, to say 0. They'll have their speed turned up all the way, and there might be, as you can see here, a little bit of drift. And now, this is not actually gyro drift. This is the system responding to a joystick command because there is no deadband, and I have my speed all the way up on the pan axis. So it's actually reading a joystick command right now. So we can bring our speed back to a normal value, give ourselves a little bit of deadband here, maybe around 5, and it's perfectly stable. So a little bit of deadband is nice for having, again, basically mitigating issues with joystick command. So we recommend having a deadband value of around 5 to 10 to make sure you're not accidentally commanding one of the axes. And then the last value here in control is expo, which is an exponential curve that's applied to the command. So with expo at 0, the joystick's output is linear from 0 to 100. So for every bit that you move the joystick, it is incrementing linearly. That might seem intuitive, but what people actually tend to want is a little bit of joystick expo applied so that when you're around that middle area, you have more precision for control, but then as you move the joystick greater at the very end or the extent, you still have a high rate of speed. Expo values typically around 70, 60, somewhere in there are pretty common. And again, this gives us nice precision around this middle area, but we still have a lot of action at the end of the joystick for doing those big moves. Big feature that's been added in the 1.1 firmware for LT and for Titan is of course follow mode. And I'm very proud of our follow mode because unlike some of the other follow modes that exist in the world, you are not limited by what kind of control input you have while follow mode is enabled. For instance, within the FreeFly ecosystem, when follow or majestic is enabled, you do not have wheels control. You do not have control of that axis. But with our follow mode, you can choose between joystick control, wheels control, and have follow mode enabled, and it works just great. This is a configurable follow mode, so you can change the character for exactly how you want the system to be following different axes. So we have two global parameters up at the top here, and these are applied to both pan and tilt. Deadband, of course, is how much you are allowing the axis or the frame to move outside of the gimbal before the gimbal starts to correct to that frame's rotation. And then expo, just like the control note that I had mentioned earlier, is do you want there to be an exponential curve applied to that, where it's a little bit softer around the middle point, or do you want it to be linear, so it's applying the same kind of change or the same kind of correction. So with expo at low or 0, you have a tighter follow, and with it higher, you have a little bit softer of a response as, say, the tracking vehicle is going around a corner. Of course, we have an on-off button here for you to be able to turn pan or tilt follow on or off. Strength is just how strong of a follow is being applied. So of course, lower strength, it's gonna be a little bit smoother, a little bit, you call it sloppier. With higher strength values, it's gonna apply a stronger correction to that, and it's gonna feel stiffer. Smoothing lets you apply some kind of smoothing or damping at the end of the follow move so that it's a little bit softer as it reaches the target. With no smoothing, it's gonna work to get there as abruptly as it can, but with smoothing, it's gonna soften that a little bit on the tail. Window is basically the range that you will let the axis deviate away from the target before it's gonna apply 100% of the motor's power to get it back to the target. So a bigger window will let the axis deviate more before it corrects back to the target. And of course, a smaller window will apply all of that motor strength sooner so that it's a bit of a tighter follow. So now let's get into wheel setup. I'm gonna go to my home menu and I'm gonna go to wheels down here. And assignment of the Titan wheels is really simple. If you remember, we connected them in no particular order, and this interface is where we determine which wheel does what. So you can see they're just doing a steady green blink, which means that each of these wheels is available for assignment. So I'm gonna go to the axis that I want to assign, in this case pan, I'm gonna press assign, and then it instructs me to press the status button on the wheel that I want to become pan. So I'm gonna have this one be pan. So it went from a steady blinking green to a solid green. That means it is assigned. And now I have my pan axis assigned to this wheel right here. I can do the rest of the wheels assignment in the same way, tilt and roll. And now I have my tilt axis here and my roll axis here as well. Now looking at the physical wheel itself, we also have some configurations here. We already talked about the status button for assignment, but this also functions as a wheel pause. So if you ever wanted to reposition the wheel or walk away without someone bumping it, you can just press that button there and it pauses the wheel. We also have a speed potentiometer here, which of course allows us to choose between a range of gear ratios. So you can really crawl with this wheel for some really precise movement. And of course, then you have at the higher end of speed, you can move it for some more of your whip pan moves. It's important to note that when you do have wheels configured here, these speeds that are up on the controller don't do anything. These are not the speeds for the wheels, these are only the speeds for the joystick and however the controller is configured. And then we also have mechanical drag on the wheels as well. So we can turn this up, and this is of course adding mechanical friction onto the wheel so it is harder or more physically difficult to turn. This can be helpful. Some operators like to have a little bit of resistance, but again, total operator preference. Now, if you're looking to use third-party wheels like the Noto inertia wheels with Titan, we'll have a separate breakout video that's all about the MotoCrane serial adapter and how to configure the Noto wheels for best performance with LT. So look on our YouTube channel or our website for that tutorial video. Next up is FI+Z, or focus, iris, and zoom. And when we built our payload, we added those lens control motors, and so we're ready to get into configuration and making sure that lens control is mapped how we want it to be. For some, this functionality is not important. You're always going to have an AC on set with their own lens control system, and that's fine. But this can also supplement that in the event that you wanted to just have maybe zoom be on a lens control motor for the operator while the AC is running iris and focus. So you can use this in any fraction. You don't need to use all all three of these motors or all three channels, but it's really there to supplement or be as much or as little of the production as you'd like. In this case, we have all three channels plugged in. You can see that the status for each of the three motors is not calibrated, but it is connected. In the event that we were to unplug a motor like this, you can see that it goes from not calibrated to not connected, and that motor is now grayed out, or that axis is now grayed out. So helpful where you can kind of by axis troubleshoot if there's any connection issue or something like that. So I'll plug my focus motor back in here and we'll get into configuration. Now, before we calibrate, we want to go into configure and choose the preset that most accurately corresponds with how loose or stiff this lens is to rotate. Newer lenses are going to be on the stiffer side, where maybe older vintage lenses are going to have looser rotating elements. And this just makes sure that you have enough calibration power without too much that might actually be damaging to the physical end stops of that lens. So I'm going to choose stiff here. I'm going to load that preset. It's going to bring me to my FI+Z configuration. This is actually what was loaded. I want to make sure that my motor model is correct. So in this case, I'm using MotoCrane motors. We also have compatibility for Hedon M26s, the M26 with the 512 PPR encoder, the 21s, Preston DM2s, Red Rock Torques. So we also play nice with other models of lens control motors as well, and you can choose those here. So you gotta make sure that you have the appropriate cable for LT, since it is a smaller connector on the LT side. Now we can get into calibration. So I'm just gonna simply press calibrate. You can see all three barrels of the lens rotating there and calibrating. And we have successful calibration on all three axes of the lens: focus, iris, and zoom. Now, the typical configuration for how you'd map focus, iris, and zoom on the controller is with focus here on this knob, zoom on this rocker joystick on the side, and then iris on this smaller pot here. This is fully configurable, and we'll get into channel mapping a little bit later in the video, but you can see here I have focus on this knob, I have zoom here on this rocker, and then I have iris on this pot. Now within FI+Z configuration, I can change things like how fast the motors move or respond to my commands, smoothing, and then also the direction of the motors as well, depending on what's intuitive for you as an operator and how you want focus to change as you're racking. Now, if you ever experience a calibration fault on one particular axis, you can always go into the configuration menu and increase the calibration power on any particular lens control motor. So in the event that you were to get a calibration fault on iris, say, you could come into the FI+Z configuration and press calibration power and increase this maybe 10 to 20 points and reattempt calibration, and it's likely that that calibration fault would then go away. Typically what happens in a calibration fault is there's not enough power applied to the motor during calibration, where it actually can't reach the end stops successfully. So you just have to apply a little bit more calibration power. In FI+Z configuration, you can also increase and decrease the amount of torque that the motor is applying to the lens. This is particularly helpful for low speed operation, where you want to have enough torque being applied to the motor to overcome any kind of small jitters. Within the 1.1 firmware update, our firmware team has done an amazing job to really overhaul the control loop for our lens control motors, which is benefiting not only those using the MotoCrane lens control motors, but all the third-party motors as well. So we're really proud of what we've achieved here to really build a world-class lens control system. Within presets, you can also save 2 different custom profiles as well. So let's say that you started with medium and had to increase calibration power on one particular axis. You can save that preset to a custom 1 or custom 2, so that you know in the future you can just load one of those profiles instead of having to load the medium one and then have to increase it on one particular channel. Next up on exciting features is for our tracking vehicle friends. This is Shake Generator. Now, when we launched Big Titan last year, this was a popular addition to the Titan ecosystem, and I'm really proud of what we've created here. This is a fully configurable native shake generator that basically operates by injecting noise into the target angle. So while LT, of course, is a stabilized head, sometimes you're doing some automotive work, you're doing a project that requires a little bit more energy in the footage, you can use Shake Generator to create that energy. So walking through some of these parameters that you can configure to create the effect that you're looking for, at the top we have these master levels. So this is going to be applied to the entire look. And the reason why that's important is sometimes you have a look that you like, and you just want to turn the whole thing up or down without having to do it on both axes. So I have a look here that I put together that's a mix of pan and tilt. And if I turn on that master look, you're going to see the whole thing start shaking, and it's going to be on pan and tilt that it's doing that shake. But of course, I can turn the whole look up or down just by effect affecting master. So if I bring master way down, I can dial the whole level of that look up or down. So it is still shaking, but I've just reduced that amplitude of the look a lot. I can also adjust the frequency. So frequency is just how often does the effect happen. So I can turn the master frequency up, which makes it more of a faster shake compared to something if I bring frequency way down is going to be a much lower frequency shake. So it's going to be happening less often. And again, this is just to the liking of the DP or again, the kind of look that you're trying to create. And then random is nice where you're trying to create something that's more organic. You don't want it there to be like a clinical, constant moving back and forth that feels like it was kind of created out of a box. You want it to feel like it's really bumps in the road or again, whatever is inducing shake through the support into the camera to create that energy. Random is one of the things that helps us do that by offsetting the noise injection that happens to help it feel more organic. So it's not something you can see is happening at a set pace. And then of course, down below, you're able to adjust the look on each axis. So on pan and on tilt, you have amplitude and you have frequency. Amplitude is how far away or how big the move is going to be away from the target angle. And then frequency is how often it's happening. So a low amplitude, high frequency is gonna be more of a buzz, and then a high amplitude and low frequency is gonna be more of kind of a nodding effect. Shake generator is also assignable as a hotkey. So you can go into your channel mapping and actually assign the master turning on or off of the shaker mode to a hotkey. So in this case, I have it set to user 1. You can see here of my list of assignable functions to this hotkey, and I have it set to shaker mode. So if I go back here and I turn this on or off, you can see I'm actually toggling the entire look on or off. So this is helpful so that you can be somewhere else in the menu or looking at tuning, but still be able to turn the shake generator on or off with the touch of a button. And you can see here as I'm toggling the axes on or off, the shake gets contained to wherever the look is left. So right now pan is off, tilt is on, and roll is off. Typically, the most common that I see is tilt and pan for shake. Roll doesn't do so much for the shake effect, but it is available in the event that you want to do that. And I can turn tilt off and turn pan on, and we're gonna have just a pan axis shake. And then if I bring amplitude back up, you're gonna see that much more aggressively on the pan axis there as well. And we can dial this up again as much as we want, kind of to our liking. And then with the hotkey, I can turn the whole look on or off as I'd like. So really helpful again for building that special effect in the camera. There's really nothing better than being able to shoot that, get the real motion blur in the frames in camera. So Shake Generator is there to add that creative effect for those dynamic sequences that you're shooting. And when you're using Shake Generator, you still have the ability to use the joystick or wheels just as you would be operating traditionally. And how Shake Generator functions is, again, it's injecting noise into the target angle. So instead of it being a perfectly zeroed out perfect gyro reading, it's actually introducing noise to get the camera to shake away and move away from the target angle to create that shake. So it's always going to return back to that target angle, but it's kind of intentionally bumping it digitally to create the shake. So you still have control over all three axes as it's still doing its shake. So again, really nice and versatile. If you're ever looking for diagnostic information on LT, you can go to Monitor and get kind of a dashboard view of all of the connected devices. Broken out into wheels, controller, and system. Right now, the wheels section is available, of course, because we have wheels connected. In the event that I unplug these, that gets grayed out and it shows me the potentiometers for what is installed, which in this case would be the controller. And if I bring these up, you can see how it's showing me the position of those speed potentiometers. As soon as I have wheels connected and assigned, it's going to gray those out and then automatically update to wheels as it assigns my wheels back to those axes. Also in controller, you have the ability to see any of the joystick channels or where the position is of things like the focus knob or any of the installed input modules. And then system is going to show me vitals of the gimbal. So there's going to be temperatures on critical circuits like motor drivers, also things like angle of the IMU and encoder, and then also motor power as well. And if we go into our scope menu, this is a handy way to view that gyrometer that is available in the tuning page, but with a little bit more of a time scale. I can zoom in or out based on how much time I want to see. And then as I move this, you'll see that I'm able to basically show some gyro rate. And I can bring this back in and get a better view of kind of what's happening based on the amplitude of the gyro rate. Of course, as I'm moving, we're gonna see that gyro rate. I can also turn on motor power as well. So say I just wanted to look at pan gyro and pan motor power. This is showing me the motor power being applied as well as the gyro rate. So another handy tool for really looking at the nuts and bolts of how the system is operating in a lower level view of how gyro stabilization is functioning. We also have a camera control interface built into the Titan controller as well. And this is done via that cam port that you saw earlier on the LT base bar. In this case, I'm using the red DSMC2 body, and I'm gonna plug in the appropriate cable here. I'm gonna start link and populate the values that I do have control over, like raw mode, ISO, shutter angle, and also color temperature. And I can change this just in real time. Color temp as well. And then this also allows me to use my record button as well. We just want to make sure that that is mapped in channel mapping to record, and then I can start and stop the camera here from the Titan controller. Currently, we support linking with the DSMC2 bodies from Red, but this is an aspect of the Titan controller that's going to continue to get updated as we add supported camera bodies to the library and also add things like broadcast integrations as well. The last section that we're going to walk through on the Titan controller is our system page. And this displays all of the firmware versions that are loaded onto the system. Also gives us access to channel mapping, wireless settings, and also configuring range of motion limits on the gimbal. And also gives us calibrations for the controller and also doing calibrations on the IMU. We also came through the system page to get to overrides, which we use for remotely powering on or off the gimbal, as well as remotely arming the motors. So let's take a look at channel mapping. This is where we configure the Titan controller to be our own as operators. Now, the standard configuration for the Titan controller is to have a 2-axis joystick on this side and then also a focus knob installed on the left-hand side, but these are user interchangeable modules. And then depending on what we have installed, we can assign different functionality. So let's demonstrate this by swapping out the focus knob here and putting in a single-axis joystick and remapping zoom to be on that joystick, which is currently over on channel 8 on the rocker here. So I have a joystick module here, and you can see I have my gold pins or my gold contacts here on one side. So this is a joystick module that can get installed into either of the input module slots on the Titan controller. So I'm going to start by removing the focus knob by loosening the 4 M3 fasteners at the 4 corners of the input module. So with all 4 screws removed, I can pull out the focus knob, and it's going to update to show me that there's actually no input module installed in that pocket. And take my single axis joystick and pop it into that slot. So on the interface, you can see as soon as I put the joystick in, it recognized that this is a joystick, and also it is a single axis joystick. So it's going to show me the axis that it can move in, and it's going to gray out the axes that it can't move in, so I'm not assigning things accidentally. So when I installed the joystick, I got a warning for my status. We can press our status and warning button right here. And this tells me channel 6 needs to be calibrated. Channel 6 is the joystick that we just installed. So in order for the controller to recognize the ranges of that control, we need to go through a joystick calibration. And this is also done from the system screen that we're currently on. So I just go to channel 5, 6, 7. So whichever calibration needs to be done, I just press start calibration. Ask me to move the joystick to the neutral position. I confirm. Pull it backward to the limit. Confirm. And then going forward to the limit and confirm. And now when I go into channel mapping and I choose that I want to have zoom on this, I'm now able to control zoom using this joystick. So it's really easy to change out aspects of the controller and map different axes or controls based on how you want to use it as an operator. In the same way, you could put tilt on this joystick. You could put a horizontal single axis joystick over here for the right hand if you wanted to have pan and tilt, kind of like a flight head style control surface, but you can really map whatever you want. We also have a couple of hotkeys, so user 1 and user 2. Most common here that people want to have are going to be leveling roll or leveling horizon, but we also talked about the ability to turn shaker mode on or off. You can map the record functionality down to these, and then you can also turn limits on or off if that's also important for your application. So a lot of things that you can do here to make the controller exactly what you want. So moving on, we also have a section for wireless settings. Now, when we ship an LT and a controller to you, those units are a linked radio pair. But let's say that you're a current Titan owner that already has a Titan controller and Big Titan, and you're just adding the LT gimbal to your ecosystem, and you only have one controller. Well, one of the ways you can make sure that you have a successful wireless pair is by using a COM cable like we have here and doing a bind between those radios. So this would have been the same radio module that you'd have been using with your Titan, but you want it to bind instead with your LT. So as long as you have a cable connected between your controller and your gimbal, you can go ahead and do a bind. It's going to give a unique bind ID, which just populated here, and that's kind of a password that the two radios use to talk to each other, and then you have a successful radio pair. Now again, you can use that in the event that you were to swap out this wireless module for, say, an upcoming 900 megahertz module, or if you needed service on one of these, an SMA connector broke off. This is kind of a factory binding that you can do very easily on your own. Another really cool feature that we built into wireless settings is the ability to auto scan the wideband that you're operating on and find the exact channel that is best or least congested for your operation. So if I go ahead and I unplug my COM cable here, so I know that we're operating wirelessly, and then I press auto scan, it's going to use the receive antenna on the controller to basically sniff out all of the available channels and select the best ones for me to be transmitting and receiving on. You can see it populated two new values for our transmit and our receive, and also gave me the exact frequency, which is 2.410 and 2.430 respectively on transmit and receive. And it's suggesting that these are the best channels for me to be operating on. While they're yellow, that means that they haven't been applied. So I just press apply, and once they get stored in the system, we can now operate. So with motors on, I'm now operating wirelessly on what we believe to be the best 2.4 gigahertz channels for transmit and receive. Now let's configure some range of motion limits for LT. Limits is something that we've completely overhauled the interface for in the 1.1 firmware update and made it really intuitive to set limits or end stops for the range of motion of all three axes. So let's say that we want to set a right and a left end stop for pan. All that we need to do is pan to that position. And let's say that we want this to be our right end stop. I'm going to press set limit here under my pan axis and on the right hand side for that limit. And then I'm going to go to the left and bring it to my left end stop. In the same way, press set limit here. It's going to tell me what that encoder angle is that I'm setting it to. And while my pan axis limit is currently turned on, my master limit is turned off. So I want to turn this on as well. And now I should have my end stops there for operating on that axis. Now, there's another parameter here that's applied to all three, which is called brake distance. And this is essentially a safety margin that you can add in addition to the limit to prevent any kind of overshoot. So if brake distance is at 0, it's effectively like hitting a wall. It will go up to that limit as far as it possibly can, and you'll see it here, and it will look like it literally hits. Bam. And bam. But having some brake distance is helpful because it softens a little bit into the limit. So typical value I think is around 100. You can bring that up to 150 or so if you wanted it to be a little bit softer. So now as I approach the limit, there's going to be a little softening that happens as I hit that limit. And of course I can increase that all the way up to the maximum here if I want it to be as soft as possible for an operator. And as I get there, we have a nice ease into that limit. Setting limits on tilt is the exact same. You can just tilt up to however high you want to go for your limit. Press set limit here for your upper limit. Bring it on down for your lower limit. And press set limit here. And then turn those limits on. And now as I bring it up, I'm going to hit that limit there. And I can no longer go any further. And then as I spin the wheel, we should stop at that lower collision limit. Again, a really simple way, instead of having to numerically dial in your limit, you can just say set limit here. You can also do this on the spine as well, and with motors off, physically move the gimbal to wherever you want it and set the limits that way too, which is nice. We do offer two different types of limits. The collision limits that you see here are based on encoder angle or the joint angle. We also offer steering limits, which are based on the IMU angle. So you can see as I toggle between these two things, it's showing me the degrees from the encoder here for the collision limits. And then when I go to steering limits, it's giving me the degrees from the IMU. So you can read more about that in the operation manual, but we do offer both types of limits, which is unique and a competitive advantage over other systems which only offer one type of limit. So the last section that I want to go through on the system page is the calibrate section, which is used for controller and IMU calibrations. So you saw me go through this with the joystick that we installed, but let's do something else here just so you can see how this section performs. So let's choose a channel and do a calibration. I'm going to choose channel 4, which is going to be this rocker here on the right-hand side. I'm going to press it, and it gives me this notice telling me that it's going to turn motors off out of safety while we're doing the calibration. I'm going to confirm. The first prompt it's telling me is to move the right rocker to the neutral position. I'm going to press confirm, and then pulling the right rocker backwards to the limit. And now while I'm at the limit, I'm going to press confirm, and then the same for the other way. I'm pushing the right rocker forward to the limit, and then pressing confirm. And now I'm calibrated. So very simple interface. The step-by-step makes it easy to do on the fly. And again, it's easy to calibrate anything in the event that you were to see that on your monitor screen, if any of these joysticks or any of the installed modules was maybe at like 52 or 53 or 47 instead of 50, that kind of shows that it's in need of calibration because it's not centered on a neutral value. And then in the same way, we also offer some IMU calibrations, which are easy to perform. The most common of which is the gyro calibration, and this is calibrating the gyroscope. LT does do what's called an online calibration, meaning that throughout the system as it's operating, it is doing real-time gyro calibrations to assist with things like drift, but you can always do a gyro calibration on demand as well. Let's press gyro calibration. It's going to prompt me to lock the tilt and the roll axes. And then while the system is not moving, I can press start, and it's going to run through a gyroscope calibration, and now it's completed and calibrated. So I can unlock the system now and continue with use. We also offer some more advanced IMU calibrations, such as IMU alignment, accelerometer alignment, and magnetometer calibrations, but we recommend that those only be done under advisement from MotoCrane technical support. So there you have it, that's the system page. It gives you the full suite of calibrations as well as the channel mapping and wireless settings and the ability to configure limits. So we've gone through a full system build out, including payload assembly, mounting and balancing in LT, and also the build out of our operator station with the Titan controller and Titan wheels, and configuring the system to be exactly as we want it for our operators. I'm Zach from MotoCrane. Thank you so much for joining me for this video. If you have any questions about LT or any of the features or things that you've seen in this video, make sure you get in touch. We'd love to hear from you.